Chapter 4, Derivative Applications, Section 4.1, Rates of Change, Example 2. So determine where the following function is increasing and decreasing. A of t equals 27t to the power 5 minus 45t to the power 4 minus 130t cubed plus 150. To determine where a function is increasing or decreasing, we first need to find its derivative. So the derivative of a of t represents the rates of change of the function. So a prime t equals 135t to the power 4 minus 180t cubed minus 390t. So this is the first derivative of the given function. So next, to find where the function is not changing, we need to set the derivative equal to 0. So a prime t equals to 0. So we first factor out the common term, which is t. So it will become t times the quantity of 135t cubed minus 180t squared minus 390 equals 0. So this one gives critical point at t equals 0. For the cubic part, 135t cubed minus 180t squared minus 390 equals 0. It's simplified and solved for other critical points. To get the critical points, we will be using the quadratic formula, and using the quadratic formula on the reduced equations, it gives t equals negative 1.159 and t equals 2.492. Thus, the function has critical points at t equals negative 1.159, t equals 0, and t equals 2.492. So to determine whether the function is increasing or decreasing in different intervals, we need to check the sign of a prime t around the critical points. The sign of the derivative tells us if the function is increasing if it is positive derivative, or decreasing if it is negative derivative. So for t is less than negative 1.159, the derivative of t is greater than 0, so the function is increasing. For negative 1.159 is less than 0, the derivative is less than 0, so the function is decreasing. So for 0 is less than t, less than 2.492, the derivative of t is less than 0, so the function is still decreasing. And for t is greater than 2.492, the derivative is greater than 0, so the function is increasing. This concludes the analysis of where the function is decreasing and increasing is based on the derivative.